Into now.
Hello guys, welcome to our presentation. We're Team 4, also known as pAWs Patrol. Our project today is to help find fewer homes for pAWs. And I'm going to introduce you guys to some of our team members today. We have Danny, who's a technologist. We have Brian, who's a staff technologist. We have myself, who's an engineer. We have Tommy, who's a technologist. We have Leon, who's a technologist, and Laura, who's a lead technologist. Our agenda today, we're going to have project overview. We're going to talk about some of the technologies we use. We're going to talk about the architecture and design in our project. We're going to have a brief demo. We're going to talk about some of the challenges and issues we faces, lessons learned, and future design improvements to make our project better overall. And we're going to end briefly with a Q&A. All right, so now for our project overview. Our customer is BARK, Bravo Animal Rescue Coalition. And what we wanted to do for BARK is we wanted to provide the metrics for characteristics of dogs that are being adopted and having a difficult time being adopted. By providing metrics, what we mean is we're going to provide breed and age within these dogs, and we're going to show which breeds are being adopted more and what's the age of these said breeds. So for example, if a younger dog's being adopted more, that would be played into a factor. We want to enable BARK for a better target marketing effort to assist these dogs with the characteristics to find their fewer homes. So we just want BARK to provide a better marketing effort for different dog breeds and for different dogs of ages so they could find a fewer home. Now, some of the technologies we use AWS IAM, py API, Python as our scripting language, AWS S3, AWS Lambda, AWS SNS, Amazon DynamoDB, AWS QuickSight, Amazon CloudWatch, and GitHub for our repositories. These are a lot of technologies, but we're going to go over more in depth in our demo and our architecture and design. And now I'm going to pass it to Laura so she can talk about our architecture and design.
Thank you, Christian. This slide shows our architecture. We start at the bottom left-hand corner with petfinder.com. The goal of PetFinder is to provide details on animals that are available for adoption in your particular area. PetFinder has an API called PetPy that rescue organizations all over the country can use to upload information on the animals that they have available for adoption. Currently, over 11,500 shelters and rescues participate in the program. On the PetFinder website, you specify your zip code and other criteria regarding the animal you would like to adopt. For example, you can specify just a dog or a cat, or you can specify a particular breed and other animals as well, besides dogs and cats. Then PetFinder displays all the available animals that meet your criteria in your area so that they can connect you to the rescue. Other organizations can also use this API to download information from PetFinder to use in their particular applications. And that is how we used it. And we used Lambda functions to pull the data from PetFinder and manipulate it so that we ultimately ended up displaying graphs of our metrics in QuickSight. Once the graphs are created, we can export them and provide them to our customer. We made use of S3 buckets and DynamoDB for storing our data. We also used SNS to send email notifications to our team when new data has been pulled from PetFinder and when the data has been sent to DynamoDB. Finally, we use CloudWatch to collect metrics from our environment, and we use GitHub for our repository. Now I will hand the presentation over to Danny and Brian, who will demo our project and talk in more detail about how we made it all work. Thank you.
Thanks, Laura. So a couple things that we got started was we created the proper roles for each of our Lambda functions. And each role has a specific permissions to access certain resources. Next up, we also set up SNS notification. So whenever our Lambda functions are triggered, our team will be notified instantly for each Lambda function. Next up is we created two S3 buckets. One is storing raw data, which is watchdog storage. And then the second bucket is storing structured data, which is being pulled from our DynamoDB to S3 bucket in a JSON format file. Next up, we created a DynamoDB table. It's currently empty, but during this demo, I will show you how this gets populated. Next we have is a Lambda layer, and this Lambda layer is where we imported our Python modules, which allow our Lambda functions to run with certain modules that is calling for. And each Lambda function has a layer attached to it. So our first Lambda function is pulling our data using the Pet Finder API from a 30-day span, and it's pulling about 100 records. And followed by that, once it gets the proper data, it's going to put it in a JSON format and then place the file in our S3 bucket. And then lastly, it will send us an email notification whenever that is finished running. Go ahead and run this. All right, moving on to our next Lambda function. This Lambda function will only trigger whenever there is a JSON file detected in our S3 bucket. And once there is a JSON file in our S3 bucket, it will check to see if there's data in our database. If there is, we'll go ahead and delete it. But for this demo, we already go ahead and delete it already. Next is it's going to grab the file from our S3 bucket and place it into a variable where it passes into another variable where it tells the variable to add into our DynamoDB called watchdog.db. And then lastly, our next Lambda function will be triggered whenever there's data inside our DynamoDB. So once data is detected, it will take all that data and export it to our S3 bucket. And I'll go ahead and show you our DynamoDB. And these are the records. And I'm going to hand it off to Brian, who's going to demonstrate how we utilize our JSON file with QuickSights.
Thanks, Danny. So the first thing I did to get our data to show up in QuickSight was I created a data set using a file in our S3 bucket called watchdog QuickSight. It uses a JSON manifest file that I had created and placed within the bucket so that QuickSight would recognize and accept the source file. And once I did that and I created the data set, I'm also able to go in here and set the schedule for the data to be pulled. We currently have it set to run daily, but you can also change that to be run hourly, and you can do a manual refresh whenever you'd like, which I'm going to do now as part of the demonstration. And once the data has been refreshed, it pulls it into our analysis page where we can use that data to create the graphs that we'd like to use. And for these graphs, I used a couple data points that we originally used in our script API, which include things like adoption status, gender, and dog breed. And I created a few charts using them. And the first graph that I created is a bar graph that separates it based on adoption status. And we have adopted on one side and adoptable on the other. And if you hover over it, you're able to see a count of all the adopted and adoptable dog breeds, and it lets you to see which ones are the most popular. The second chart that I created using this information, it was a pivot table. It had similar metrics to the first one, but it also broke it down into the age of the adopted and adoptable dogs, breaking it down into baby, young, senior, and adult. And this view allows you to get a more granular perspective on the different dog breeds that are currently available and have been adopted. And the third chart that I created in QuickSight was a pie chart. And the reason I created this pie chart graph was more to easily visually represent the numbers that are getting pulled in and changed within our QuickSight graphs, and you're still able to see the different dog breeds and the number of them as well. And we hope that this data can be used to bring more awareness to the dogs that are still out there and hope to help them get adopted faster. I'm going to go ahead and pass it off to Tommy for our lessons learned.
Thank you, Brian. So for challenges and lessons learned, initially we were wanting to use a Twitter API to pull our data from Twitter, but we foresaw some potential issues with pulling unexpected data. Eventually, we found the Pet Finder API, which was perfect for the data set that we wanted to use. It gave us all the information that we needed. Next was GitLab. So when we were trying to import our code into GitLab, we were running into some issues due to the changes in the naming structure of the branches that GitLab had made. We were unaware at the time. So eventually we settled on using GitHub instead. Next is the IAM policy, just ensuring all of our services had the correct policies and roles in place to communicate with each other and transfer data between each other. After that was identifying the methods for displaying the graphs. Eventually, we settled on using QuickSight. So we had to come up with the way to get it to work and configure it and do some research to get that accomplished. Next, for a lesson learned, debugging with the correct Python version. Just ensuring you're debugging with the correct Python version. Checking that first could save you some time in the debugging process. Next is automating the deletion of data into the table. Just configuring it to set up to automatically delete the previous data that was in the DynamoDB table prior to pulling in the new one. The new data into the table, we had to do some research to get that to work correctly. And for the last point, configuring JSON file to read through AWS QuickSight. During our research, we found a lot of information on configuring CSV files to read through QuickSight, but not as much on JSON. So with a little bit of trial and error and a lot of research by the team, we were able to configure that properly and get that working right. And Brian did an excellent job with that. And with all that being said, I will pass it to Leon for our future improvements.
Thank you, Tommy. For future improvements, our first one is we wanted to pull raw data directly into DynamoDB. Right now, we have it go to the API to a S3 bucket, then DynamoDB. We just want to make sure, it's a direct connections for that. For streamline automation of info into AWS QuickSight, we just want to create a better automated process for what we have right now. Open source alternatives for AWS QuickSight for cost savings. The alternative we're looking at is Tableau, just so we can avoid the cost of AWS QuickSight. It has good graphing orientation. I really like it. Our last one is add online web application, just creating a user-friendly website for people to see data on dogs, and they're able to refresh the page to see updated results as well.
And that concludes our presentations. Any questions?